Okay, so today we're going to move on to acceleration. We've already done different types of speed. We've talked about average speed, we've talked about instantaneous speed. The actual calculation of speed has not been difficult because we know the formula from telecoms, so we should remember that distance is speed times time, speed is distance over time. Now we're doing acceleration. Acceleration takes the concept of what speed is and allows us to do some more calculations and investigate what's actually happening. So the first thing we need to think about is be able to explain what is meant by acceleration, and then be familiar with the acceleration formula and be able to use it to calculate, be able to state the difference between v and u. Okay, so acceleration. Somebody tell me some place that they've heard the words acceleration before. Great. Okay, what? Top Gear. You've heard the words acceleration in Top Gear. Okay, so what do they say about acceleration in Top Gear, Craig? Acceleration makes the car go fast. So you don't need an engine, you just need acceleration.
It's how fast it goes to get fast.
How fast it goes to get fast. How fast it's gone to get fast.
Well, how quickly it speeds up.
How quickly it speeds up.
The time it takes to get to top speed.
Right, so the time it takes, but the time it takes, surely that's time, not acceleration.
No, but
That's another word for it. Okay, so what we're saying is the time it takes to get to top speed. Well, that's not really technically correct because that's the time it takes to get to top speed. That's not acceleration. But what I'm saying is how fast it takes. So how fast it can go from one speed to another. So normally, if you're talking about acceleration from rest or from standing, you've just got how fast it can get from 0 up to say 60 miles an hour. That's how fast its acceleration is. And that's the length of time it takes. The shorter length of time, the better. Okay, so it's about increasing speed. It starts at one speed and it can accelerate up to a faster speed. Now, not only do car manufacturers are we interested in 0 to 60, but most car manufacturers also give you the 30 to 70, which is like your overtaking speed. How fast can you accelerate to overtake? So normally you're going at 30, you want to go up to 70. And sometimes that's a better statistic than 0 to 60. How many times have you ever been in a car where you're standing there going from 0 to 60? Most times you're on the motorway, you're on a dual carriageway, and you say, right, see how fast I can go, put your foot down and accelerate round things. Okay? So it's usually 30 to 70, it's a bit better. But that's still a time. So we want to know what acceleration is in terms of calculations. How can we, by the way, you two not talking to one another? Is that why you're sitting so far apart? Okay, so let's look at what I mean by acceleration. So let's think about an object. Let's think about an object along a road. Here's a road. Oops, that's not a road. Here's a road, okay. I'm going to put a car on the road. It's a very aerodynamic car. It's been developed by NASA to go as fast as possible on roads. You wouldn't believe it, but this is the best shape possible. Okay, the car, a few minutes later, a few seconds later, is here. Somehow it's managed to get longer. I don't know how. But aerodynamics, see, it gets bigger. It's all to do with Einstein and everything, all these relativity rules and all that. See? Right, so the car starts off at 10 metres per second. The speed, what we can maybe say just now is the speed is 10. Okay, just say the speed is 10. This one here, the speed is now 20. Now, without using the words metres per second, because metres per second can get quite confusing, we're going to say that this point here and this point here. Now, every time I mention speed now, I mean instantaneous speed. I don't mean average speed. If I mean average speed, I will say the average speed. But when I just say speed, I mean instantaneous. So when I write the word speed, I write v, I mean instantaneous. I mean the speed at that point. Unless I put a bar above it, it's not average. So we're going to say the speed at this point instantaneously is 10. The speed at this point instantaneously is 20. And between these 2 points, we're going to say that it gets from here to here in 1 second. So if it gets from here to here in 1 second, and it's 10 metres per second here, 20 metres per second here, by how much has the speed increased per second?
10.
Don't shout, please. So Matthew said 10 metres per second. So the speed increase per second is 10 metres per second. So the speed increase per second is 10 metres per second. Let's say that it now takes 2 seconds to get from there to there. What is the speed increase per second, James? 5 meters per second. Okay? Right, let's change it again. Let's say that this is now not 2, let's make it a different number, let's make it 3 seconds. Alright? What is the speed increase? In fact, 3 is not a good number. Let's choose another number, let's make it 4. 4's fairly straightforward. So let's say it takes 4 seconds to get from 10 meters per second to 20 meters per second. The speed goes from 10 to 20 in 4 seconds. What is the speed increase per second length? What is the total speed increase? What's the total speed increase? It goes from 10 to 20. 10. You can do 10, you can do 20 minus 10, you can work out the speed increase. Okay? Speed increase is 10. So it took how many seconds to do that speed increase? 4. So per second, what did it increase by? 10 by 4 is not even. 10.5 is an even number.
A whole number.
2.5. No, it doesn't have to be a whole number. Hang on a minute, I've been doing physics for the last 2 years. It doesn't have to be a whole number every time.
Oh, no.
You're in credit maths.
I know
It doesn't have to be a whole number. No, it can be points or fractions or whatever. So, 2.5 what? 2.5 seconds? No. Right, okay, stop. It took 4 seconds to go from 10 to 20. So per second, it increased by 2.5 meters per second. Okay? So per second, so we would say that per second, it increased by 2.5 meters per second. So what we can say is the acceleration equals 2.5 meters per second, which give us, we won't write it like that, we'd write it like this: A equals 2.5 ms to negative 2. Instead of being to negative 1, we say to negative 2. Now when we did space topic, we talked about this a little bit, but this is me now going into a lot more detail. Okay, so now we know the acceleration is 2.5 meters per second squared. So what that is the amount of speed it's increased by per second. Alright? Okay, so let's try and summarise that. Take your jotter please, write the heading, acceleration. So, the acceleration is the rate at which an object's speed has increased per second. So, how many meters per second has it increased by per second? And that gets us meters per second, which is ms to the negative 2. Right, you get two different types of acceleration. Right? You get standard acceleration, which you are getting faster, and you get acceleration, which you're getting slower. What do we call acceleration when we're getting slower, Stuart? Not de-acceleration, but deceleration. So you have acceleration and you have deceleration. Now, in physics, acceleration is a positive number. Deceleration is just negative acceleration. It's just a negative number of the normal acceleration. So we have two different types. You get speeding up, something speeding up or getting faster. So if object speeds up, then that equals a positive number, a positive acceleration. And we don't have any other word for that. It's just acceleration is something speeding up. If the object slows down, then we say that is going to be a negative acceleration. So when you do your calculations, you might get a negative number. So it doesn't mean it's wrong, it just means that it's negative. It's slowing down instead of speeding up. And we could also call that deceleration. So it might be called a negative acceleration or a deceleration, but either way it's just a negative number. Please bear in mind that deceleration has no symbol. Acceleration has the symbol A. Deceleration has no symbol because really you just put a negative in front of the A and it's the same thing. Okay? So, that takes us on to the formula which we're going to use to calculate these. We have to go back to a little diagram that I showed you a minute ago. Alright, so to get acceleration we need the speed it started off at, the speed it finalised at, or that it ended up at, and the time it took to do all that. Okay, so if I go back to a little diagram we did, here's a little diagram. This 10 would be our initial speed. So this 10 we give the symbol U. U is the symbol for initial speed. Then we get 20, which is our final speed, we give that a symbol V. So there's V and U. And we have a total time which equals T. So T, V and U. On this diagram, V there, U there and T there. Okay? So we can now use these three symbols to get us our acceleration, which is A. So let's do that. The formula you need is A equals V minus U over T. Put this in your drawers. Acceleration. And that's measured in meters per second to -2. Notice the -2, not a -1, equals final speed minus initial speed, and that's all divided by time. That is in seconds. Final speed's in ms to -1. That's in ms to -1 as well. Okay? Now the problem is going to be you cannot use a triangle for this. So anybody that's still using triangles, shame on you. You should not be using triangles still in physics. I've given you enough rants about using triangles. Okay? Triangles to rearrange your formula. Oh. Okay? Exactly. You don't, because we have now got four letters, we can't use a triangle, and you don't want to start thinking of whatever other geometric shape you can use. So just get away from using triangles at all, or shapes at all, and think about how we're going to rearrange it on its own. So let's do that now. Now look at the board when we're doing this. Let me explain it first before you're going to just put it down your jotter. We start off with our initial formula. A equals V minus U over T. We might need to rearrange it for three different things. We might need to arrange it for T, or V, or U. So let's rearrange for T first of all. So to get it for T, you start off with the formula A equals V minus U over T. You want T on its own, so you first of all, it's hard to get it out from underneath the formula, so move it over to the left on its own first. So you have AT equals V minus U. And then you can just get rid of the A. So you have T equals V minus U all over A. And there's your formula for getting T. Okay, right, stop. Wait till I've finished. Next one, you want to get V, for example. So you start off with A equals V minus U over T. You want V. This gets a bit more difficult because you've got a multiplication, a division, addition and subtraction all mixed up together, and you want to try and get the V out. The first step should still be get the T over. Then you want to get rid of the U. So that's a minus U. What do we do to get rid of a minus on one side, Jason? Add. So we add the U to both sides. So it's AT plus U equals V. That ends up being V equals AT plus U. Now, I'm just, for the sake of my own benefit, we're going to put V equals U plus AT, which is the same thing. And that's a very important higher formula, V equals U plus AT. We don't really use it that much just now, but you would use it in higher a lot. And then finally, we want to get U out of the equation. So we start off with A equals V minus U over T. Get the T over. AT equals V minus U. Now, what do we do next? We want to get rid of the V, but how are we going to do that? What? Who knows how to get rid of that? Get rid of the V there. Right. Would it not be easier? Would it not be easier? Now that U's got a negative in front of it, so if I try and move the V from the right, I'm going to have to still hang on to that negative, which is a bit of a problem. So the easiest thing I can do is get the U to become positive to start with. So we do exactly what we did before. AT plus U equals V, and then we can just subtract off the AT. u equals v minus at. Okay? 3 different ways of doing that. Take a note of them, please. 1, go. Right, okay. So, right, let's look at page 61 in your textbook. Question number 12 on page 61. Question number 12, page 61. Okay? Okay, can you not share, boys?
Oh no.
Right, question number 12 on page 61. Now, it's important that we start thinking back into the groove of answer numerical question technique, which is on the website. Oops, whose pen was that? I just crunched. Thank God it's not mine. Right, answer numerical question technique, which is on the website, should you forget it. But the first stage in answer numerical question technique is pull out the information from the question. Okay, so Ailey, give me something in that question that's important and give me the symbol for it. 12. Question 12. Trolley takes 7.5 seconds to reach 6 metres per second from rest. Calculate the acceleration. What piece of information is useful from that question that we can use to get the answer, and give me the symbol for it? 7.5. 7.5, and what's the symbol for that?
T.
T. Time equals 7.5 seconds. Is this in standard physics units, Robert?
Yep.
Yeah. Right, next piece of information the question is given us then, please, Shannon. What? Listen, I'm asking you a question, stop chatting to Lynn. God knows 2 of you need to concentrate more. Come on. Right, 7.5 seconds. What are the other things from the question do we need? Can we pull from that? 6 what? What is that? What is 6 metres per second? Is it feet? But what is it? It's a speed, right? It's a speed. Okay? And this is what we have to decide. Is it initial speed or final speed? So it trolley takes 7.5 minutes to reach 6 metres per second from rest. So is it the final speed or the initial speed then? That we're looking for. That 6.5. That 6 is given us. JP?
Yeah, it's fine.
Final speed. So V equals 6. Is that standard physics units then, please, John?
Yeah.
Yes, it is. So it's meters per second. Good. And then, what other piece of information can we pull from the question? Declan?
U equals 0.
How do you know that?
Because it's like from rest.
From rest. Good. So U, initial speed, equals 0 ms to -1. And we want to know A. -1 is your speed, -2 is acceleration. Okay, so we look at the data sheet, we find the formula, it's got all those numbers in it, it's very easy. E equals V minus U over T. We don't need to rearrange it because we've got the one we want on the left hand side. Plug the numbers in. 6 minus 0 all over 7.5. And that gives us what? Stuart, give me an answer. So it's 6 over 7.5.
0.8.
0.8 metres per second to -2. Right, okay, just to recap as well, listen, look at the board. Just to recap, in a question, in an exam, you'd have half mark for the units, half mark for the answer, half mark plugging numbers in, half mark for the formula. But if you get the answer right with the units, you get full marks, but this is the marks we're trying to aim to achieve. Get all these marks ticked off and get in the habit of doing it every time. So, I want to carry on. I want you to do question 13 and get as far as you can. Another class got to about 19, so we're looking to get to about 19 on that page in the book, please. Right, on you go.